All right, this video is about analyzing graphs of polynomial functions, and today we're going to do some rough sketches of graphs of polynomials. So I'm going to guide you through what it is are the important points. What do I expect you to be able to identify and get right on the graph? With these sketches, they're sketches, okay? That means that not everything has to be exact, but there are some things that the person who's grading your test is going to look for to see, do you know these important things about the graph? All right, so we're going to start off with the degree, the leading coefficient, and that's going to tell us the end behavior, just like in 5.2 that we just studied. All right, so for this polynomial, the degree isn't obvious because this is not in standard form. Okay, we don't really want it in standard form because this factored form is going to make this easier in the long run. But let's see if we can use what we see to figure out the degree. Here I've got a x times, over here I've got an x squared. All right, I'm just thinking about what is that first term going to be. All right, I've got an x times an x squared. So this is going to be an x to the third. That's going to be my first term. There's going to be a bunch of other stuff that's happening. So this x here gets the power of 2. These two multiplied together gives me the power of 3. So the degree is 3. The leading coefficient is going to be 1 times 1 times the negative up front. So it's going to be negative 1. All right, so I've got an odd degree, and I've got a leading coefficient that is negative. So the end behavior, okay, odd means the ends point in different directions. Since it's negative, this means this is decreasing. Okay. I'm going to say this in an English sentence instead of saying it algebraically right now because it's going to be more helpful to you in the long run. The left is going up so that the right can go down. That is the end behavior. I said that in English instead of saying it in algebra. All right, now what else do I need to know about this polynomial function? I'd like to know the x-intercepts. Those are going to be really important points that the grader of your test is going to look for. All right, this is already factored for you, all right? So it's factored form. So you don't have to multiply it out. It's giving it to you in the easiest form you need to graph it. All right, what I'm going to do is I'm going to take all of my factors, x plus 2, set it equal to 0, and I'm also going to take x minus 1 squared, set that equal to 0, and I'm going to solve both equations. All right, here I'm subtracting 2. Gives me x equals negative 2. That's one of my two x-intercepts. Here I'm going to take the square root of both sides. I have x minus 1 equals 0. And then I'm going to add 1. X equals 1. Okay, that's the other x-intercept. Two x-intercepts. One of them is at negative 2, 0. The other one is going to be at positive 1, 0. The y-coordinate of any x-intercept is always 0. Identify the multiplicity of the zeros. All right, well, here's what that means. Since I have power of 2 on the factor that gives me 1, we say that the coordinates 1, 0 has a multiplicity of 2. Okay? The factor, the root negative 2, 0 has a multiplicity of 1. All right, so that's going to be helpful when I graph it. All right, what else am I interested in? I'd also, okay, here's something to take down in your notes, all right, before we move on to the next thing for the graph. A root of multiplicity 2 tells you that a graph touches but does not cross the x-axis at that intercept. All right, pause the video, put that in your notes. That's going to be important again in another minute. Okay, so now what I want to do is I want to find the y-intercepts. To find the y-intercepts, I'm setting x equals 0. Okay, so I've got f of 0 equals negative 0 plus 2 times 0 minus 1 squared. Be careful with your signs here. Be careful if you are tempted to skip steps. I'm going to bring that negative down. I'm going to simplify these parentheses. 0 plus 2 is 2. Now these parentheses, I'm going to simplify inside the parentheses first, gives me negative 1 to the power of 2. Be very careful with your order of operations and your signs here. My exponents come next, so negative 1 to an even power is a positive 1, and negative 2 times positive 1 is negative 2. So the y-intercept is 0, negative 2. The x-coordinate for the y-intercept is 0. 0, negative 2 is the y-intercept. Okay, so I'm going back to the thing I'm going to first start and graph is the x-intercepts and the y-intercepts. The x-intercepts and the y-intercepts. All right? Those are going to be the most important points on my graph. So let's just plot those 3 points. I've got a point at negative 2, at 0, positive 1, 0, and a point at 0, negative 2. Okay. Now what I want to do is I want to connect those points, and I'm going to use the other things that I know about the multiplicity and the end behavior of this graph. I'm going to make these points bigger. They're here on this graph already, but I'm going to make them bigger for you. Okay. So we know about the end behavior. This is a decreasing graph. Okay? So the left end goes up, the right end goes down. Okay? The graph is, so it's going to start from up here somewhere. Okay? And it's going to end down here somewhere. All right, and then there's some squiggles in between. All right, the graph crosses the x-axis at negative 2, but only touches the y-axis at positive 1. So let's see if we can draw that. So I'm going to cross the x-axis at negative 2, touch this point here, touch positive 1, but don't cross the x-axis there. And so that would be what I'm looking for. I did a lousy job at making this curve smooth. Hopefully you are a little bit better than what I'm trying to do here on the smartboard. Make your curve smooth. It's going to be important when I grade your paper that I'm looking for end behavior, I'm looking for x-intercepts, y-intercepts, and whether or not the graph is crossing the x-axis or only touching the x-axis. All right, and I'm going to do another example. This time more quickly because I've already explained the vocabulary and the basics here. I've got the root x plus 2 equals 0 gives me x equals negative 2. The factor x plus 4 set equals to 0 gives me x equals negative 4. So I'm going to make a table of xy coordinates. I've got a point at negative 2, 0, and a point at negative 4, 0. Let's discuss multiplicity right now. So here I've got the point negative 2, 0 is a multiplicity of 2. That is going to be only a touch, not a cross. And the point at 4, or negative 4 I should say, is also a multiplicity 2. So that also is going to be a touch, but not a cross. Okay, so the graph is only touching the x-axis there. It's not crossing the x-axis there. All right, the degree, I've got x to the power of 2 times x to the power of 2 gives me x to the power of 4. So the degree is even. And the leading coefficient is positive. All right, so that means degree even, leading coefficient positive, both ends up. Okay. All right, I'm going to get ready to graph this now. I've got a point at negative 2, 0. I've got a point at negative 4, 0. It's only touching the x-axis at those 2 points. So what am I going to do? I'm going to come from positive infinity, touch, up, touch, back up. Rough sketch. The important points here are covered. Oh, you know what I didn't do? I didn't do my y-intercept. Teacher's going to take off some points. So let's find my y-intercept and make a correction there. I'm going to plug in x equals 0. So I've got f of 0 equals 2 times 0 plus 2 squared. Let's start over. Probably should have made some more room here. Let's make some more room. Okay, I'm going to plug in x equals 0. F of 0 equals 2 times 0 plus 2 squared times 0 plus 4 squared. All right, order of operations, simplify inside the parentheses first. Exponents, 2 to the power of 2 equals 4. 4 to the power of 4 equals 16. 8 times 16 is 128. All right. All right, that means way, way up here. All right, since that point would be so high off the graph, you wouldn't be held responsible for that point. So there you go. I mean, that's what we'd be looking for when doing a rough sketch of a polynomial.